Okay, so when we have these things identified, now we're going to set up a table of values. So you're going to have to do two of them. Do the left side, and then you're going to do a right side. All right, everything's based off of the vertical asymptote. So x, f of x, f of x. All right, so my vertical asymptote is at 3. So what I need to do is pick a point that's a little smaller than 3, which is 2.5, and then another point smaller than that. So go 2 and then 1. And then to the right, we're going to go a little point bigger than 3, which would be 3.5, 4, and then 5. Okay, and then I'm going to post another video that has you doing this in Desmos, and in Desmos will show you very quickly, or you can do it in a graphing calculator, all right, what your values are. So when we put 2.5 in, we get -4, then -2, and -1. Then we get 4, 2, and 1. Alright, so that's our points for the graph. I have my vertical asymptote, my horizontal asymptote. Now we got to do domain, and then we'll do range. Alright, so our domain, I guess we should plot the points first. It'll probably be easier to see then. Okay, so I'm going to graph my vertical asymptote, which is at 3. So I just draw a dotted line. Okay, and then I'm going to do my horizontal asymptote, which is at 0. Then I label them. F of x equals 0, and x equals 3. Now for the graph, plot the points. 2.5 is all the way down at -4. And then 2, -2, and then 1, -1. And connect these points with a nice smooth curve, getting close to the asymptotes, but never actually touching them. Okay, and then on the right-hand side, 3.5 is 4, 4 is 2, and then 5 is 1. Again, make a nice smooth curve. And there is our rational function. So our domain, again, is all my x values. So we're going from left to right. As we can see, like left to right, use a different color. We start at -infinity here, and we keep going. And then we hit a wall, which is this x equals 3. So there's a gap here. And then we go from there to positive infinity. So to write that out, we say -infinity to my vertical asymptote, which is 3, union. Okay, that's how we join it. So basically we're jumping over that wall or line, if you will, and then we continue on all the way to positive infinity. Okay, and this point right here, this will always be your vertical asymptote, always. So that's an easy thing to remember. Now my range, remember, is our y values, or us going up and down. So I'll illustrate it here. So we start down here at -infinity, then we go all the way up to this horizontal asymptote, and then there's again like the little wall. Then we go all the way up to positive infinity. So let's illustrate that with interval notation. So we start at -infinity, and then we go all the way to 0. Jump over it, so the union symbol, it's a big U with no tail. And we go from 0 to positive infinity. And that's it. So if we need to, make up the notes nice and cleaner, I'll erase all this stuff. Okay. The perks of watching the video. Alright, so our next one is 1 over x plus 2. So let's label. A is 1. H is -2. Again, x plus 2 can't equal 0. X can't equal -2. And then we have k equals 0. H is always our vertical asymptote. K is always our horizontal asymptote. So let's plot these two things first. Go to -2. Say x equals -2. Then I go to 0. And then f of x equals 0. Let's do my table. So left, and then the right. And these are left and right of the vertical asymptote. Okay, so my vertical asymptote is -2. So a little to the left of -2 is -2.5. Then -3 and -4. So only one decimal and the rest are whole numbers. So just once you get close to the asymptote without actually touching it. And then to the right of -2 would be -1.5, -1, and 0. Then again, plug into Desmos or your graphing calculators to get these values, which will be -2, -1, -0.5. We get 2, 1, and 0.5. Okay, so now I'm just got to transfer and graph the points. So -2.5 and -2, -3, -1, -4, and 0.5. On the other hand side, we have -1.5 and +2, -1, 1, and then 0.5. Draw our curves. Okay, and there's your graph. So I just got to do our domain and range now. So domain, start at -infinity. Then we go to our vertical asymptote of -2. Jump over that line and go -2 to +infinity. My range, start at -infinity. I go all to my horizontal asymptote, which is 0. Then we jump over that line. Go from 0 to +infinity. Again, this is always your vertical asymptote. This is always your horizontal asymptote, okay? So those are the only things that change. It's always -infinity, vertical asymptote, union, -2, or I'm sorry, your vertical asymptote to +infinity. All right, always the same there, all right? And it's a parenthesis at -2 and 0 here because we don't actually touch the line, so we don't use a bracket, we use a parenthesis instead. That illustrates us getting close but never actually touching it. All right, so example 2, we did just a shift left or right, and now we'll move on to left or right shifts and up or down shifts. So we're going to throw the K into the mix here. All right, so example 3, part A. A is 2, H is 4, opposite sign there, and K is 2. Again, x minus 4 can't equal 0. So x can't equal 4. Vertical asymptote. So x equals 4. F of x equals 2. All right. Vertical asymptote, horizontal asymptote. Table. So to the left of 4 would be 3.5, then 3, and then 2. To the right of 4 would be 4.5, 5, and 6. Well, again, I always just go 0.5 to the right of the vertical asymptote and 0.5 to the left. And our values, when you plug them in, you get -2, 0, 1, we get 6, 4, and 3. Plot my points. 3.5 and -2. 3, 0. And 2, 1. 4.5 and 6. 5 and 4. 6 and 3. Make my curve. Kind of spinning the iPad as I'm drawing it to make the curves look nicer. So it's my little cheat. Alright, domain. -infinity to your vertical asymptote. And then jump over the line, vertical asymptote of 4 to +infinity. Range, -infinity to my horizontal asymptote of 2. Join it, jump over it, and then 2 to +infinity. Okay. And then our last one. So we have the reflection here. As you can see, A is not positive. So A equals -3. And quick sketch, so normally our graphs have been looking like this, right? So when we have a reflection, they look like, instead of being in quadrants 1 and 3, they are in quadrants 2 and 4. That's all reflection is. Okay, so just in different locations. My H is -1, K is -4. Oops. So we're used to saying H or write H. So X plus 1 can't equal 0, -1, -1. X can't equal -1. Again, vertical asymptote for H. K is my horizontal asymptote. Table now. Table time. So left side, got X, f of X. It's a little to the left. Actually, let me draw it. Make it easier to see. -1. So X equals -1. And we got -4. There we go. It just helps me visually see where I'm going to put this. So to the left of -1, -1.5, -2, -3. To the right, X, f of X. And we get -0.5, 0, and 1. The values of these are 2, -1, -2.5. And we get -10, -7, and -5.5. Alright, plot our points. -1.5, +2, -2, -1, -3, -2.5. If you add more points, it'll get closer and closer. So the decimal values will get smaller and smaller and get closer to the line but never touch. And on the other side, we have -0.5, -10, 0, -7, and then 1, -5.5. Draw our graphs. Okay. So there are our graphs. domain and range, domain, negative infinity to the vertical asymptote of -1, jump over the line, -1 to positive infinity, or range, negative infinity to a horizontal asymptote of -4, jump over the line, -4, positive infinity. All right, there we go. So we have some shifts. See our horizontal asymptote moved around for these ones, but again, it's not too bad. You just got to label your A, H, and K. You do a table to the left, a table to the right. Before that, I would draw my vertical and horizontal asymptotes. Make sure we label them, it's very important. Okay, and then you do your domain and range. And again, download Desmos to your phones, watch my video that's coming up, and you should be able to figure this out pretty easily without using that thing you guys have been using. Alright, and then our word problem. Alright, so an airline has a daily nonstop flight between Los Angeles and Sydney, Australia. One-way trip is about 7,500 miles. We're going to write an equation of this, given the formula, rate times time equals distance. Okay, so right here we have miles, that's my distance. And we want the equation in flight speed, so that would be rate. So the formula, rate times time equals distance. We know distance. It's an easy word problem. And then we'll solve for rate. Okay. Now our restriction is time can't equal 0. Alright, and we can't have negative time, so actually let's change this. Okay. So time actually has to be greater than 0. Alright, I'm going to do this problem on Desmos so you can see what the graph actually looks like. So in real life situation, you can't have negative time because you're always moving forward in time. Alright, so and then are there any real life limitations? So when an airplane's traveling, there's gonna be some limitations. And I'm gonna post this probably as a question on Google. So I'm gonna see what your guys' responses are. Alright, enjoy the video. Good luck. Email me if you have questions.